So it is 1:20. We are going to get started. Question. What? Yeah. Oh, so I'll work with you with that afterwards. So who has written a loop before? You've written a loop in Python. All right, that was most of you, not quite all of you. For those who didn't raise your hands, I'm going to guess either you're too lazy to raise your hand or you're going to struggle during this workshop. If you've never written a loop before, this is going to be very challenging. For the many of you who raised your hands, you've written a loop. You're probably in a good place here. Who has written a list comprehension before? So little fewer of you, but many. So you are going to have some review here. We're going to review list comprehensions first, then we're going to jump into some more advanced topics in Python. So for loops. This is a for loop. We've got a list of numbers. We print out the numbers. If I wanted to, using a loop, make a new list of numbers, say doubled numbers, that was each of these numbers multiplied by 2, how could I do that using a loop? I've got an empty list. What do I want to do next? What's your guess? For n in numbers, yeah, by the way, this is an interactive tutorial. In case you didn't guess from that question here, I'm going to be asking you a lot of questions. You don't have to be the one who answers the question. But every once in a while, you might want to challenge yourself to maybe speak up. If you find if you're the one answering all the questions, maybe halfway through, start to silence yourself a little bit, let other people speak up. But I'd like you to challenge yourself. Either challenge yourself to be a little quieter if you're the one answering the questions, or to speak up if you're not. So for n in numbers, what's the next step here? Somebody else. Print? Yeah, so I could print these things. I want to stick them in this doubled numbers list, though. How could I stick it in the list? Append. So doubled numbers dot append. What would I append to this list? Yeah, that value. The same thing would be printing that n times 2. So we're doubling the numbers. After this, my list has the numbers all multiplied by 2. So this is a really common thing to do in Python. By this, I mean taking a list and building up a new list out of it. We loop over an old list, we build up a new list out of that, changing each of the values along the way, maybe filtering it down. This is such a common thing to do. We have a special syntax for it in Python. Doubled numbers equals, that open bracket there, because this is a list we're working with, n times 2 for n in numbers. So this here is the same thing as that for loop there. For those of you who've seen list comprehensions, you already know this. For those of you who haven't, this is something new. So this comprehension we wrote here, why is this such a common thing to do in Python, by the way, to take an old list and make a new list out of it? Why don't we modify old lists in Python? We do modify lists, but what's the downside of modifying a list? Anyone know? Right, yeah, if you change a list while you're looping over it, bad things might happen. That's true. What else? Case you're referencing the old one, right? You might be referencing the old one. More than that, though, Python has kind of a unique feature. If I say numbers2 equals numbers, and I say numbers2 dot append 4, how many things will be in numbers2? What's your guess? 5 things? Oh, I wasn't raising your hand. That was 5 things. You meant 6. Okay, you didn't have 6 hands, though. You raised one. You were hoping a 6th finger would appear. So 6 things should be in numbers 2. We've got 6 things in numbers 2. How many things are in numbers? What's your guess? 6. We have 6. So if you're coming from another programming language, depending on what that programming language is, this might be unexpected. JavaScript, this is the same way it works. Java, this might be a little bit confusing. The assignment signed in Python, when you do an assignment, nothing gets copied. This tutorial is not on this topic. If this topic is confusing, which I'm sure for some of you it is, because it's a little bit of a weird thing to see if you haven't seen it before, I have some talks to recommend on this, there might even be a tutorial I could recommend on this. List comprehensions are such a common thing in Python because we have this. Because we have an old list that might be referenced by us, we might want it later. We might also have it referenced by someone else. Our coworker in their code has that list. They passed it off to us. they don't want us to go about changing it on them. They'll be upset about that. So we make a new list out of it using a list comprehension. This is the short syntax for building a new list out of an old list. All right, so list comprehensions, I prefer personally to write these things a little bit more like this. So I'm going to make a file that has that for loop that we wrote. So I'm going to say numbers equals a list of numbers, and I'll say doubled numbers equals an empty list for n in numbers. Doubled numbers dot append n times 2. So I'm doing the same thing we did before. I want to copy paste my way from this for loop into a comprehension. So who was in my tutorial with me last year that I gave last year? Okay, a couple of you. So for those of you who weren't in it last year, I'm glad because this is a little bit of review. If you've seen comprehensions before, there's going to be some review here. But we are going to copy paste our way from a loop to a comprehension, which is probably something you've never done, even if you've written a comprehension. So the first thing I want to copy is these square brackets. What is the next part of this comprehension? What's the next thing I might want to copy from that for loop that comes after that open square bracket? N times 2. Yeah, so it's n times 2 because it's the thing we're appending. Whatever that thing we're appending is, we want that next. What comes after that? What's your guess? Yeah, the loop, this part. For n in numbers, we don't want that colon, but we want the for n in numbers. So a comprehension has the same parts as a for loop. If you ever have a for loop that looks like this, empty list, looping, changing a little bit, and appending, you can always copy paste your way into a comprehension instead. Now notice I wrote this over multiple lines of code. Before I wrote this all smushed together on one line. How is it that Python allows me to write this on multiple lines of code? Normally when you hit enter, your line is done. Python is white space sensitive. Why does it allow me to hit the enter key here? Yeah, those square brackets. When you were inside of a square bracket, a parenthesis, as long as you've got one of those open, Python knows there's more to come. So when you write your list comprehensions, I would recommend you write them over multiple lines of code for the sake of readability, for your coworker's sake, and your own sake in 6 months when you read your code. So list comprehensions, they have another part of them. We're kind of mapping our comprehension. We're taking these numbers, we're multiplying each of them by 2. We can also filter numbers down. For those who've written a comprehension before, what would I add to this to filter numbers down? Anyone know? Yeah, not aware. That's kind of SQL syntax, but we've got something similar. If, yeah. So for those that, for where, if you were thinking where, if you've done a database query, this is very similar. We're taking things, we have a condition that we want to check. If something. Now, I don't know what this something would be here. Maybe we could say we're only going to double our odd numbers. So we'll say doubled odds. How could I ask if a number's odd? Yeah, if it's remainder when you divide it by 2 is equal to 1 or not equal to 0. So these should be doubled odd numbers. Let's see what our actual numbers were before we execute this. So numbers is 1, 2, 3, 5, 7, 4. So what should doubled odds be?
3, 5, and 7, and 1.
Ooh, what did I do wrong? Yeah, so I got doubled evens because I did this. This should be equals 0, thank you. So, something I didn't do, maybe for the sake of those of you who came in a little bit late, I didn't introduce myself. My name's Trey. Hi. You're in the right room if you're here for lazy looping. If you're not, you're here already. Somehow you snuck in, so feel free to stick around. The way that I teach is we're in a Python Repple together, which is a Python command prompt. Same thing. Anyone know what Repple stands for? Python Repple? This is a term a lot of us use. We don't really know what it means. Python shell, Python command prompt, Python Repple. There's a lot of names for this thing. Whenever you've got these 3 greater than signs, you are in the Python Repple. So Repple, I believe, stands for read, execute, print, and loop, or read, evaluate, print, and loop. Python's reading what it is that we're typing. When we hit enter, it executes what we just typed, and then it loops or rather it prints out the result, and then it loops. It waits for us to keep on typing. So we're in the Python REPL here. I'm going to be in the REPL or in a Python file in my text editor. I'll be using Vim. You should use whatever you are comfortable with. Quite a bit. About half the time, I'll be up in front of you all writing code, and I'll be asking you things and expecting you to occasionally shout things out. The other half of the time, I'm going to have you individually working through exercises. That is on the website, which is what I had on the screen when we just got started, or rather as you were kind of coming in the door. That's the wrong year. PyCon 2019. And I think technically that's HTTPS. So we're going to be going to the website. That both acts as my script as well as a repository for the exercises we will work through together in a little bit. I use a sticky system when I teach, as a lot of folks who teach tutorials do, which what I mean by that is I don't have a sticky to demonstrate. If you have a question, not while I'm up here, but while you were working through exercises individually, I would like you to put up a red sticky on the top of your laptop. So if I'm standing up in front of here, you raise your hand to ask a question. What is it hard to do while you're raising your hand? Type, yes. So while you are working through exercises, I would like you to put up a red sticky for your sake, because I don't want you to have to worry about flagging down me or flagging down any of the TAs. So we have, there's 3 TAs today, Melanie, Jason, and Nicole in the back of the room. They are all somewhat new to generators as well. So you are going to be working through code together. They're going to act as your rubber ducks, and I will act as your rubber duck. Anyone know what a rubber duck is? I mean, you know what rubber ducks are, presumably. They're ducks made of rubber. Anyone know what rubber ducks are for? Yeah.
They're right on your PC and you talk through what went wrong.
Right, you talk to the duck. So when you have a problem, you talk to your rubber duck. You explain what your code does. Maybe you ask it questions. It doesn't usually, well, it shouldn't answer the questions. If it does, you've got a different situation. Your rubber duck is what you talk to. So the TAs will act at least as your rubber duck. The rubber duck usually gets you half the way to solving the problem, if not the whole way, because oftentimes it's just elaborating on your question that helps you answer it. So we're going to be practicing rubber duck debugging in a sense with the TAs as we work through exercises. We've got a sticky system is what we use. And I just showed you the last part of comprehensions there. Just before we jump into exercises, I want to ask, are there any questions? Any questions you all have for me right now? I guess what I mean by that, any questions you want to ask in front of 60-some people? Okay, if there's any questions you, yep. Is this session recorded? It is recorded, yes. You will have access to it. So sometimes the recordings don't always work well. Usually, 90-some% of the time, I would guess most of the time, the recordings work out fine. There's a full 3 hours of recording. You can see and hear me okay. You can mostly see the screen, which is the more important thing. They go up on YouTube pretty quick, so I would guess by the end of the week, probably they will be on the internet. What I will do is the website that I just put up here, I put the YouTube video embedded in that website, so you can reflect on this afterward. While I'm typing up here, you don't need to type along with me. Everything I'm typing is recorded. It's all on the website. Feel free to ask questions, sit back. If you want to type something out and try it out, please do. I want you to play. The way that you learn is not by putting information into your head. It is by attempting to retrieve information from your head, attempting to recall information. So I want you to play. I want you to attempt to recall these things by doing the exercises. And I want you to play and ask questions by attempting to recall things from your head, ask questions of me and answer questions. But yeah, it will all be recorded, and you can watch it afterward. So for those of you who have questions you don't want to ask in front of 60 people, we're about to take an exercise break. Please put up a red sticky if you have any questions at all, if you're stuck during the exercises, if you need any help. So the exercises, they are on the website. I'm going to put some instructions up here for you because the very first exercise break is going to be rocky. This is the rockiest part of the tutorial together because you need to download a zip file, extract it, make sure you have Python installed, and make sure everything works. After we've gone through that, it's going to be a little bit easier. So on the website, if you have not yet gone through the test framework section, please download the exercises zip from the test framework section, extract the exercises.zip file, and then start working. Well, put up a green sticky at that point, please, and then start working through list comprehension exercises. So the reason I want you to put up a green sticky after you have got the test framework, you've extracted it, you made sure it seems like it works, is because I don't want to move on until all of you have at least got the test framework set up. And then we are going to be working through probably the first exercise, maybe another one after that together. So please work through one of these exercises. I purposely put more exercises on the website than you could possibly get through in the time I'm going to give you. And I'm going to give you about 10 to 15 minutes here. I'll check how we're doing on time in a little bit, probably about 15 minutes. So put up a red sticky when you get stuck. You will probably get stuck somewhere in here. If you have no idea what's going on, just put up a red sticky. Someone will come by and chat with you. If you get stuck at any of these steps, put up a red sticky. If you have a question on that very first exercise, which is get val names, as you'll see in a moment, put up a red sticky. All right, I'm going to be wandering around the room along with the TAs to chat with you all. So a little bit of confusion on the website. I meant to update something that I didn't. Test.py. So I'm gonna go grab this exercises zip file that you are grabbing right now and show you how you can confirm that it actually works. So I've got the zip file. I'm going to extract it. I'm doing that from the command line. You can do that however you'd like. So I've got an exercises folder here, an exercises directory, Python test.py. Now I am on Linux. If you are on Linux or Mac, you will probably want to type Python 3. If you are on Windows, you may need to type py or py space -3. If you get stuck at this point, put up a sticky. Test.py is _OK, is_OK. This is going to print out a little success message. This is the way you can know that the test framework actually works. If you're not confident in the test framework working, you got the zip file, you don't know whether your Python works, this is what you can do to see that it works. After that, work through these exercises. Start working on that first exercise. So I realize what I just said was probably confusing. I'm going to wander around the room, and when you get stuck on something, put up a red sticky. We're going to chat. So I asked this before you all came in. Who got an email from me last week? The email that I sent you last week had a zip file in it. I said you could download it. It was the wrong zip file. So delete that zip file. It is the wrong zip file. Download this zip file now on the website. I made a mistake last week. I sent you the wrong zip file. Sorry about that. For those of you who you've got the test framework, is okay, seemed like it worked. Now you're wondering, where are we and what are we doing? What am I supposed to be working on now? On the website, in the List Comprehension section, there's a Comprehension Exercises section. Get val names is the first exercise there. In the List Comprehension section on the website, that's pycon2019.trey.io. Go to the List Comprehension section, go to Comprehension Exercises. That very first one, Get val names, is what we're working on. What it says on the website is that we want to open lists.py. Lists.py is the file we're editing, and the first exercise we're working on is get val names. So I'm going to open up here list.py just so you can see it. I realize there's a lot going on the screen. I've got a very big font here so you can read it in the back. Get val names is the one we are working on in lists.py. There are instructions on the website for how to run this. So I'm going to show you where on the website real quick. This is the test framework page. We want to jump to Comprehensions, List Comprehension Exercises. And then we are right here editing list.py. Get val names is this very first exercise we're working on. If you get stuck while working on this, put up a red sticky. This is the way you can test it. We are going to be running the test against this code together here in a moment. So any questions while you're working through this, put up a red sticky. Yeah. Myself or the TAs will come around to help.
It may be a little bit non-intuitive at first, but the file that you're editing and function in is different than the file that you call test. So the file that you're going to be editing the function is list.py, but you're calling test.py because that's where all of this validation is happening. Hopefully that makes it a little bit easier.
All right, for those of you in the last couple rows of the room, very last couple rows, who finds this readable? You find this, you can read this. Who finds you cannot read this? This is a little hard to read from the very back of the room. All right, I'm going to bump it back up again. So it's a little bit unfortunate because it's hard to fit a lot on the screen with such a long room, but we're going to work with the limitations that we have. I am going to work through with you this first exercise. We're going to talk about what it is that this exercise is, and then I'm going to let you do it on your own. So I'm going to show you where it is. So in this exercises zip file that you extracted, you downloaded the exercises zip file from the website, you extracted it, Python test.py get val names. This is what I'm going to run. Now, I only have Python 3 here. If you have Python 2 installed, you're going to have to type Python 3 or 3.7 if maybe you've got 3.5 or some older version as well. If you're on Windows, you may need to type py space -3. I'm going to be typing this, Python 3 test.py get val names. My tests fail. It says get val names takes 0 positional arguments, but 1 was given. Now, I ran test.py. I passed get val names to it. I didn't actually pass anything to this function. There are tests already written for this function. Does anyone know where the tests live, or did anyone kind of poke around at those files? Anyone have a guess? Lists tests? So lists.py, these are empty functions. List.py has a function get val names that does nothing, flatten. These are empty. These are skeletons. You need to actually make these do something. Lists underscore test.py, this is a very small window I'm working with here, but this is a set of tests that I wrote. Get val names tests. It imports get val names from lists, this py file that has this skeleton function. It imports that and it runs that function, passes in a list, and expects another list to come out of it. So I've written tests for your code. You need to get the test to pass. Who practices TDD, test-driven development? This is the thing that you practice. So for the majority of you not raising your hands, I sympathize. I didn't used to practice TDD. I still don't really practice TDD. I write tests, but it's more like test-inspired development. There's some tests written somewhere along the way. If you have never practiced test-driven development before, that is what we are doing here, except that I'm helping you a little bit with this. So for those who do practice TDD, what's the hard part of TDD, of test-driven development? What's the hardest part of it? Writing the tests. I wrote the tests. Your job is to get the test to pass. So I did the hard part, or I did part of the hard part at least. I wrote the tests. Your job now is to figure out how to get these tests to pass that you didn't even write. So I wrote these tests. You need to write this function such that when I execute the test against it, it does what it's supposed to. How do I get it to accept a list? It says it takes 0 positional arguments, 1 was given. This one argument is a list. What is this list going to be? What's in this list? Strings, names. So these are names, so I'm just going to call this names. And from this function, what am I supposed to return? What type of thing? Yeah, also a list. So get val names equals empty list, return val names. We have 2 failures of 3 tests. So we're 1/3 of the way done here. We've written 2 lines of code. The rest of it's a little trickier, though. You've got to actually loop through it and do something. I'm going to give you a few more minutes on this for those of you who didn't get this far. For those of you who did, keep on chugging through the other exercises. We will be moving on to talking about generators here in a little bit. Any questions at all? I'll put up a red sticky. All right, we're going to work through this together. So get val names, we accept a list of names, we start an empty list. What are we going to want to do here now that we've made a list? What's your guess? A for loop? So we want to loop through something. What are we looping through? Names. So for name and names. And what do I want to do for each iteration here? If. So we would check some kind of condition. We want to see if something is true. If something is true, what's the thing we're going to do if that condition is true, whatever that condition is? Yeah, we want to stick it inside our new list. So valNames.append. And we're going to append what? Yeah, just our name. That's the thing we're appending. This is the part that's interesting because you probably all found very different ways to solve this because there's a lot of different ways to solve the same problem in Python. So what's one way you found to solve this? Name 0. What'd you do with name 0? Check it. So you checked if it was equal to A or if it's equal to E. So we could have done this. What's another way to do this? Because I don't want to type all of our vowels. Do it in a list. So you did. You made a list of vowels. So up here I'll say vowels equals a list of each of these. So list of all of our vowels. My fingers want to type double quotes. I'm trying to type single quotes, or the opposite of that. So what'd you do with the list of vowels? So name 0, you ask if it's in that list. That did not pass our tests. Why did that not pass our tests? Capital letter. Ah, yeah, we have capital letters. How do we fix this? Dot lower, dot upper. Another thing we could do, we could stick all the uppercase, all the lowercase vowels in the same list. Any of these would work. Do I put lower, where do I put it? Here? Name 0 dot lower? Yeah, it shouldn't actually matter. Strings in Python, when you index them, what's the type of the thing you get back? What is the type of this? What's your guess? String? So if this is a string, what is x00? Also a string. What about 0? Yeah, if you're confused, this isn't the topic of this tutorial. This is something you can look into on your own. Strings in Python are technically an infinitely recursive data structure. The first thing in a string is a string. The first thing of that is a string that you can loop all the way down if you'd like. So that we get back a string, which means it doesn't matter if we put lower here or before we do the index, and either of these works. So we're going to see if this passes our tests. That does pass our test, so this does work. Anyone find another way to do this? Name 0 dot lower in vowels. We've got equals equals, we had in, anything else? Yep. A regular expression. You could absolutely use a regular expression if you want to do things the hard way, maybe. I actually gave a tutorial on regular expressions a couple years back. They're wonderful, but you don't always need them. So name 0 dot lower in val names, we could use a regular expression. There's also in Python a starts with. We can lowercase this. There's a starts with method. We can pass it a tuple of all the vowels, maybe. Starts with is one way to do it. Kind of a fun way to do it because starts with is English, which is kind of fun to see in Python. In vowels, another way to do this. Did anyone do a different data structure here besides a list? Yep.
I did a string.
You did a string? What was in your string? Why did that work? What does in do on strings? It doesn't make it into a list. It seems to do something similar to what it does with list. It does what? Yeah, it's an iterable. It loops over it in a sense. It's a substring check. So x in hello, asking if this character here, this string is in vowels, happens to work because we're looking at a single character. So I don't care how you did this. How you did it, though, however you did it, we've got a for. You have an if. You have an append. There are no list comprehensions here. I just did this with a for loop. How do I copy paste this into a list comprehension? What's the first thing I'm going to copy? Square brackets. I need the square brackets. What's the next thing? I'm going to do this over multiple lines. What was that? Name. Why name? Yeah, it's a thing I'm appending. So whatever it is I'm appending, which happens to just be name in this case, I want to put as that next thing. What after name? The loop? The if. Yeah, so this one we haven't really talked about so much here. We actually want the loop for name and names. And that last thing that we want is that if, the condition. So this here is equivalent to this down here. Questions on this? Thoughts on this? Yep. Do we need val names? Oh, you mean, can we just return this thing maybe? We can. Val names, so in Python, we don't really care so much about variables and variable names. Variables are not the star of the show in Python. Objects are the star of the show. What I mean by that is when I said numbers 2 equals numbers earlier, I changed numbers, and suddenly numbers 2 changed as well, about a half an hour ago or so. That's the way variables work in Python. Variables point to objects. So we don't care about the variable here. We can just return the object we just made. And we don't necessarily need this variable either. We could just stick that string in here as well if we wanted. Questions or concerns about this list comprehension syntax? Yep.
So maybe you covered this and I blanked, but would you recommend leaving it written out on multiple lines like that in production code?
Good question. Yeah, I just wrote this over multiple lines because it was easy to copy paste into it. We could absolutely do this. Thoughts on this? This is up to you. This is a very much a preference thing. Who likes this better? Who thinks this is what I'd like to see in my code? Who likes this better? Who likes the for loop better? Few of you like the for loop better. So list comprehensions, I prefer list comprehensions when we can copy paste from a loop to a comprehension. It's up to you how you want to do things though. And I also prefer the multi-line comprehension. The reason for that is I find this more readable. I mean, you have more lines of code here. We have more lines of code, but the name of the game isn't making as few lines of code as possible. It's making our code readable. So it's really up to you. Do you find this easier to skim, easier to scan, or do you find this one more readable? And it's probably going to depend on the use case. Is that comprehension one that really makes sense to do as a one-liner, or is it a little bit complex, you want to put it over multiple lines? The tricky thing here is I just gave you a very wishy-washy answer. You're going to need to ask your coworkers how you actually want to do this as a team. When do you want to make your comprehensions over multiple lines? When do you want to do one-liners? So great question. So comprehensions for those of you who haven't seen these before, if you are not sold on these things, that is okay, because we're going to be talking about something that's a little bit beyond comprehensions in a bit here. I would like to refactor some code together with you, though, before we jump into that. So I'm going to take what I would call an advanced stage for loop. Now, what I mean by that, I purposely am using kind of medical terms here, sort of like an advanced stage condition. For loops can get a little bit out of control sometimes. You can make for loops that are very, very big. You can make functions that are very, very big. I'm going to make a for loop that is not enormous, but it's getting pretty large. So we're going to make a file here. We're going to open a file called, what is this called? We'll say get. I'll just call this days.py. I'm not great at naming things on the spot. What this is going to do, it's going to open up a file, a gzip file. What is a gzip file? Anyone know? Yeah, it's a compressed file of sorts. It's a GNU zip file or a gzip. It's a gzip file. That's a great tautological way to not answer the question. It's a compressed file. We're going to open that up. And what that file looks like inside, if we were to extract it, which my text editor can do, it has 387,408 lines of code. So I probably don't want to read this whole file up in memory, and I probably don't want to actually manually go through this file. So we're going to open this file up. using the gzip module built into Python, we're making a set. We're looping through every line in our file that we've opened here. What does match equals user re.search do? What is this user re thing? Anyone know? Yes. For the person who made a regular expression earlier, you know the answer. It is a regular expression. You don't have to know this regular expression thing. You just have to copy paste it because that's how regular expressions work for the most part. You find them, you copy paste them, and you hope that it continues to work. So we've got a regular expression. We hope that it works because we're not going to want to tweak it. We use it to search that line of code. We use it to search not that line of code, that line in our file. We check to see we've got this match. If match, this is asking the question if we actually had a match. Because we either get none back or we get a regular expression object. If there was a match of this line of code, Farnsworth session opened for user, and then a user, we take match.group1, match.group2. What are those groups? For those who've seen a regular expression before. Yeah, those parentheses. These parentheses allow us to capture things. So it's capturing whatever this is. It's capturing whatever this is. We're going to open this file up and search for session opened for user. Session opened for user Nancy. So we're capturing the thing over here before Farnsworth. That is, oops. That's this thing. So that's a date. We're capturing a date first. And the other thing we're capturing is just after user, the username. So this parenthesis and this parenthesis. So when I mentioned you don't have to know regular expressions, you don't have to know regular expressions, but we are going to be refactoring code that uses them here. Fortunately, the exercises are not going to be this complex. So we're taking a date and a user, putting that in a tuple called day. If day not in scene, what question is that asking? Yeah, if we've seen it before. What is that scene thing? What type of thing is it? It is a set. How do sets work? Yeah, uniqueness. So we want to check, is something in this set here? They're great for checking, have we seen something before? That's kind of the type of operation they're great at. So we're asking if we've seen it before, or rather if we haven't seen it, we're going to print it out. And then we add it to our set. We add it to our set there. So if I run this code, we'll see what it actually prints out. It's running against, it's hard-coded here, against sshd.log.gz, which I downloaded that file. That is on the website. It's taken a little while, but it did print things out. It said Nancy, Taylor, Virgil. It printed out some things here. So it takes a few seconds to run, but it does print everything out in chunks there. So I want to refactor this for loop. I want to refactor this for loop to make a lot of intermediary lists using list comprehensions. And then we're going to talk about what we've done and whether it was a good thing or a bad thing. So we're going to take this for loop. What's the first type of thing I might want? If I'm starting to loop through this, I've got lines. That's the first thing. How might I want to process a line a little bit? I've got a line. I get a regular expression. I check, did we get a match? If we did, we grab things from it, and then we put those in a tuple. We check, is it in our set? And then we stick it in our set. What's the first kind of logical step we do as we're looping over those lines? Do the regex of some sort. Yeah, that's really the first thing we do is stick it in that search, do some sort of regular expression. So the first thing I'll do here is we're going to make a loop that says for line in our log file, we're going to make a list of matches. Say we've got a match, matches.append matches. Now this looks silly what I'm doing, but we're going to do it anyway because there's a reason we're doing this. I'm trying to break this up into the smallest steps possible. We've got matches. For each of those matches we check, was there even a match? Is that match something that's truthy or is it none? Is it an actual regular expression object? So we've broken up one step there, and I'm going to name this step. I'll call this find all the matches. Could we break this down any further? We check to see if there's a match. That's maybe something we could somehow break down. What else could we do? Yeah, we could kind of move print out of here somehow. Do the things that are not printing. So for match and matches, if there's a match, I'm going to say days and stick this thing inside of a list. So this tuple thing we're making, I'm going to refactor this to say, for each of these, we're going to append that day. And then I'm going to outdent this code. And we're going to do another for loop to loop over. What are we going to loop over this time? Yeah, we've got our days for day and days. I've got this scene thing. I need to go grab that set we made. So here we are making a list of the days from our matches. Days users logged in. And then here is, there's not really a way, I think, to break this down much further because that print is something we can't do in a data structure. Printing is not something we should do in a list comprehension. So we want to print out our days. So when I run this code, what is different about the code that I just wrote here? I actually don't know if it works. We haven't run it yet. Assuming it works, what's different about this code that we just refactored than the code we had before? It's flat. Yeah, it's flat and not nested, which is kind of cool. It's nice for readability in a sense. We've got our steps broken out. What else? We have multiple lists, which might be a bad idea because we're taking up extra memory. So when I run this, it's a little bit different from when I ran it before. It gives us an error for one, which it's not supposed to do. List object has no attribute group. That is on line 18. What's wrong here? What was that?
You got an append matches statement. I think it should be append match.
Oh, thank you. You're right. Yeah, Python, this is one of the downsides to Python not being a strongly typed language, or rather not a strongly typed language, it is. It's not a strictly typed language. You can just shove things into whatever and it's fine with it. Let's run it again. So assuming it works this time, this executed a little bit differently. If you remember from before, how is this different? Yeah, it took a little bit to run. It's taking probably about the same amount of time. What did it do differently? What positive thing did it do before that it's not doing now? It started printing them out as it found them. Once you find a match, it prints out that match. So we have to wait for all of them. Why do we have to wait? Right, the print happens at the very end. We build up a list, we build up another list, we build up a set, then finally we print as we're building that setup. So we're going to refactor this in just a little bit here. Well, first I want to refactor to actually use list comprehensions. After that, we're going to refactor this further to make this actually do the exact same thing that we had before while still maintaining this structure, this flat structure. So copy pasting into a comprehension. What's the first thing I copy? I'm going to want those brackets. What's after that? Yeah, that match thing. Now this is tricky. This for loop has 2 lines of code. So I can't actually copy paste when there's 2 lines of code. How can I collapse those 2 lines? Yeah, stick this into here. Remove that match line. So copy this. And I'm going to do this on 1 line of code just to show you you can. Even though I prefer to do these over multiple lines of code. We've got the thing we're appending first, and then the for. Let's make sure our code still works. It does still work. And then down here, we've got the same situation. We have if, we have multiple lines of code. How do I get rid of that? Yeah, replace that day, just shove that tuple inside there. So we've got empty list, for, if, append. This is the recipe for copy pasting from a loop to a comprehension. If you can write your code in this format, you can copy paste it into a comprehension. So I'm going to do this one over multiple lines because this is a bit longer. What's the first thing I want? Yeah, that tuple, that thing we're appending. What's the next thing? So this one's tricky because the tuple, the thing we're appending, comes first. When you have a condition, you have to remember that comes last. Everything comes in order except for the thing you're appending. We take the thing we're appending, we stick it first. All of our fors, all of our ifs come in order, the same exact order after that. So our for comes next, our if comes after that. This syntax here, if this syntax for comprehensions looks mysterious to you, some programming languages have a little bit different syntax, which might look more familiar, especially depending on if you went to do maybe higher level math classes, it might look familiar. If we have some kind of numbers, and I were to say maybe doubled equals n times 2. Has anyone seen this syntax before? Something kind of like it. Imagine that that greater than dash is an epsilon. What does that look like? I'll change this a little bit, make it look even more familiar. Did anyone get like a math major, math minor? So, yeah, so maybe the real numbers there. So this is set notation. This is set notation from, or set builder notation rather, from the math world. We stole this in Python. We didn't steal the syntax. The reason we didn't steal the syntax is in Python, we don't like symbols. We like to type things the long way. We like to type, instead of n star 2 such that n is an element of the real numbers, we say n for n in R. And we use these list bracket syntax because we're building a list here. So that's where this list comprehension syntax came from. The notation was kind of borrowed from math. All right, so copying this last one, we're making a set. We're printing these things out. There is no way to make this into a comprehension. How do I know that? It has a print. Now, there are ways to put a print inside of a comprehension. You may occasionally see people write something like this. You may have numbers, and you might say print n for n in numbers. What is this going to do? Print a list? A string with no spaces? Will it print out our numbers, one on each line? So who thinks that this will print out our numbers, one on each line? Who thinks it's going to print out some kind of list? Who thinks it's going to do something else? Lots of something else. Lots of no raising hands. I'd like to remind you, you have a civic duty. You don't have to exercise it, but it's an important idea to do so occasionally. Yep.
So the print function has a return value of some kind in addition to making output. So it should be a list comprised of that return value.
A list comprised of whatever print returns to us, right? When we said n times 2, we got n times 2. When we say print n, print probably returns something to us. What did it return to us? None. Yeah, we don't like none. This is not the greatest thing. We built up a list of none values. So it did print. It printed, which is what we wanted. We cared about the side effect. We didn't care about the list. We shouldn't use a list comprehension if we don't care about building up a new list. List comprehensions are for taking an old list and building up a new list out of them. If you care about a side effect and not building up a new list, you don't want a list comprehension. What do you want instead? How could you loop over something and do something? If you want a side effect, yeah, you could use a for loop. We have a for loop in Python. For loops are great. We use them a lot. You don't always need a comprehension. You only want a comprehension if you're taking an old list, building up a new list out of it. So we're going to leave this one as is. All right, I want to talk about a way that we can fix this problem here. We refactored our code and it made our code worse, which is something that's common to do. You refactor your code, you find you made your code worse afterward, you then revert everything you did. So we're going to talk about generator expressions. Who has written a generator expression in Python? All right, that's good. Very few of you. You've written list comprehensions. You have not written generator expressions, which presumably is why you're here. You want to learn about generators and generator expressions. We're going to talk about generator expressions first because they're kind of an easier analogy to make, especially for the many of you who've seen list comprehensions before. So we've got a list of numbers. How could I add up these numbers? Sum. There's a sum function in Python. Gives us all those numbers added up. How could I add up the squares of these numbers? If I wanted to say, total equals 0, I can't just do this. Why doesn't this work? Yeah, it's going to try to square the list. Does that work in Python? Maybe, we'll find out. Doesn't work. You cannot square lists in Python. That star doesn't work. How could we get the squares of these numbers and add them up? How could we get some of the squares? A 4? Yeah, we could say total equals 0 for n in numbers. What would we do here? Plus equals. Yeah, n star 2. We square the number, we add it to total. I'm going to guess that that's right because I can't do math quickly in my head. But we've got the sum of our squares here. How else could we do this without a for loop? A list comprehension. So what would I type here? We're not copy pasting this time. We're just going to write it out. Yeah, that thing we'd be appending, which is going to be the n squared, then what? For n in numbers. It's really the only thing left there. We've got the thing we're doing, the thing we're looping over with that doing. We've got our numbers. This is not what we're looking for. What do I do with these? Right, we had that sum function. We passed a list to it. It sums up our squares. How is this for loop different from this line of code? Creates a new list. Right, if I had 10 million of these, how would it be different? Right, a big list. We're looping here over each number individually, adding them up, squaring it, adding it up. Here, we have to first build up a list of 10 million numbers, all of the squares, and then after that, loop over that list one time to sum it up, and then we throw the list away. The list isn't stored anywhere after we've executed that line of code. There's no variable that points to it. It gets discarded. So we don't really need that list. So what does the sum function accept? What is your guess? What type of thing? I can pass a list to it. What else could I maybe pass to it? A container. So could I pass a tuple? Yeah? Could I pass a set? What's your guess? I can. So the description for the type of thing that sum accepts is an iterable. What is an iterable? Anyone know? Yeah, anything you're able to iterate over. An iterable is something you are able to iterate over. If you can loop over it, it is an iterable. So if we can write a for loop to loop over whatever this thing is, we can pass it to sum. So I'm going to make a new thing here. We're going to say squares equals n squared for n in numbers. I'm going to turn these brackets into parentheses. So when I had brackets here, what's the type of the thing that we got back? If I said squares equals this thing, type of squares, what's your guess that we'll get? A list? We do get a list. So when I turn the brackets into parentheses, what is your guess that this will give me? A tuple. Right, when we take a list, turn square brackets into parentheses, we get a tuple. We don't get a tuple. We get a generator. So a list comprehension in Python, a list comprehension is a tool for looping over some iterable and making a list out of it. We also have in Python set comprehensions. How would I make a set comprehension? Anyone want to guess? I don't use square brackets. Yes, I see you doing it. We use these curly braces, the thing we do to make a set. We also have a dictionary comprehension, which is a little bit weird. We have to put a colon in there. We're not going to talk about these. We want to talk about the fact that unlike sets and dictionaries and lists, we do not have a tuple comprehension. We instead have this generator thing. Now you can think of this as a generator comprehension. It is not called that, it's called a generator expression. If you say generator comprehension, everyone will know what you're talking about, even if they very rudely correct you potentially. Generator comprehension, generator expression, they're interchangeable terms. We technically call them generator expressions. So this thing we made here is a generator. We've got numbers here. We have squares as this generator. What's the first thing? If I say squares 0, what's your guess that this will give me? 1? Yeah, 1. If we square 1, we get 1. We do not get 1. What did we get? Yeah, it wasn't what we were looking for at all. It was an error. The length of squares. What's your guess that this will give us? An error. I'm guessing you're guessing this because we just got an error when we asked it for the first thing, so why would it know the length if it doesn't know the first thing? And it does give us an error. So what can we do with this generator thing that we just made? This doesn't seem very useful. We can't index it. We can't get its length. What could we try to do with it? Loop over it? Sum it? We could, yeah, let's try to sum it. So we'll sum it. We'll say sum of squares, and we get 104. We'll try to loop over it for n in squares. Print n. Why did it not print anything? I used it up. So what's the sum? What was the sum before? 104. What is it now? What's your guess? Who thinks it's 104? Who thinks it's 0? Who thinks it's an error? Who thinks it's hello? It is 0. So what is going on here with these generators? Yeah, they're one-time use. These are one-time use things. So you can think of these as disposable. You make a generator, you loop over the generator is now useless. We have no purpose in having this generator object anymore. We've just exhausted it, is the term we say in Python. We exhausted it, it's tired, it needs a nap. So this generator is now exhausted. We fully consumed all of the items in it. So what's the point of these things? To not use memory. Yeah, so we could test this out. We could say, instead of numbers, I'm going to make a range. Has anyone seen this notation, that underscore? What does that mean? Comma, yeah, it's a new thing in Python 3.6 and above, I think. This is essentially, you can remove those underscores in your head. So if I were to take this and say n squared for n in this, what is this going to do? Yeah, I'm not going to hit enter. I have a habit of, so I teach Python for a living. I go into companies, I work with teams, I teach Python. I have a habit of crashing my computer about once every 20 hours or so. It hasn't been nearly 20 hours, but that doesn't mean I can't crash my computer. So I'm not going to even try that. I don't want to make a list of that many numbers, but if I make a generator of that many numbers, if this didn't take up memory, I should be able to hit enter, and it's not going to complain at me. So this will be the test of this. If my computer doesn't crash, this doesn't take up memory, and it does not take up memory. At least it doesn't take up all of those numbers of memory. So what is this generator doing? How does it work? What's your guess? As I loop over it, what must it be doing? Yeah, the one we need at a time. So we can test this out by starting to loop. We could say for n in squares, print n, break. What will this print? What's your guess? So squares here is n squared for n in this very big range. What do you think the first thing will be? 1? It's actually 0. Let's try it again. What's your guess for the second one? Yes, it must be 1. It was 0 before. It is 1. And if we do the third one, what will that be? 4, right? Because we've got 0, 1, 2, but it's squaring them along the way. So as we loop over this, it is consuming values. If we stop looping, it stops where we left off. Now there's a shortcut for this. Instead of typing a for loop, printing, and breaking, if you have a generator in Python, you can say next squares. And you get the next thing from there. This is a way to manually loop over this generator. Questions on this? Thoughts on this? Concerns? Is there a previous? It's used up, so you don't think there's a previous? Who thinks this will work? We have a previous function in Python. Who thinks I spelled it incorrectly? There's a different function that does this. Who thinks this is impossible? This doesn't make any sense. Who doesn't like raising your hands? There is no previous. There's no previous in Python. And the reason for that is it doesn't know what should have come before. It's not storing any cache. If we want to store some things in memory, we're going to have to maintain those values ourselves. Generators are single use. They are one-time use, lazy iterables. Now, if we make I'm going to make the generator we had before. We had squares of just these few numbers here. If I use next to loop over these and get all the numbers, once I get towards the end here, what is your guess that this will give me? Stop iteration. So I just hit the last number. So it could start looping again, but as we just saw, there's no previous, so there's probably no way for us to restart it. So it gives us an error, gives us an exception. We're going to talk about this later, but this is something that is not unique at all to generators in Python. This actually comes up in other parts of Python as well. All right, I want to refactor together with you the code that we just made to use generators, and then we're going to jump into some exercises. So we have list comprehensions. How do I take a list comprehension, and instead of making a list, how do I make a generator object? What am I going to do to modify this line 9 here? What's your guess? Yep. I heard brackets. What do you want me to do with the brackets? Remove the square brackets, put round brackets around it. Put these parentheses instead, like this. Let's try it out. Our code didn't break, so it worked. We were able to loop over this matches thing down here. How do we know, if we were to see a list comprehension in code, how do we know whether we can turn it into a generator expression? We can't always use these. Lists are sometimes more useful than generators. How do we know if we see a list comprehension whether or not it would break our code to turn it into a generator expression? What's your guess? If we only use it once, if we use it more than once, we know that's a bad idea. We don't want it to turn into a generator expression. What other signs are there? Yep. If it's being iterated on. So if the thing we're doing with it is iterating. If we're asking for the length, we can't know that. If we're indexing it, we can't know that. If the only thing we're doing is iterating, and we only use it once, we only loop over it once. So the reason we can turn this matches from a list we can turn into a generator is we say for match and matches. This is the only time we use this matches thing in our code. This is every instance of it. The only thing we're doing is looping over it once and then throwing it away. We don't need a list. We can use a generator. All right, days. Can we turn days into a generator? What's your guess? Who thinks it'll break our code to turn days into a generator? That's your guess. Who thinks it will not break our code? It'll actually work if we do that. Who doesn't know because I didn't give you enough time to think about it? So days equals this thing. We're going to try to turn this from a list, we'll turn into a generator. And we will see if this breaks our code. It does not break our code. Our code also did something a little bit different. What did it do differently? Yeah, it started printing immediately. So this is the fundamental thing that I really wanted to talk about. The reason we're talking about generator expressions is the fact that we just took code that looked pretty different before. What did we start with here? The very first thing I started with before we did any refactoring. Yeah, it was an advanced stage for loop. It was a very big for loop. It was a for loop that had a lot of stuff in it, and we broke it into lots of little for loops. We took those, we refactored them into list comprehensions. The problem is, what was the problem after we did that? We broke this one for loop and down into lots of little ones. What did it do differently? Right, it printed at the end. It had to wait until every single thing had been executed before any printing happened at all. Here, we've just made a generator object, and we made another generator object that loops over our first generator object, this days thing. We then loop over that down here, and we print. So when I get to this line of code, scene equals set, I've made two generators. Actually, one of these is still list comprehension. There we go. I've made two generators. When I say for day and days, what does Python do? Anyone want to guess it? Try to walk us through this real quick. For day and days, what is your guess that this line of code would do the very first time we start that loop? How does it get the first day when we look in days? It can't index it because when we did days sub 0, we got an error on that generator. So it does some magic under the hood to get it. How is it going to compute it for us? Right, we're asking next. Next on that days thing, where does it get its first item from? What work does it have to do? What are we looping over inside of days? Right, matches. So it's going to say for match, and matches is the very first thing I have to do before I can ask any question of match, before I can make any tuple. So we go up to matches. When we're at matches, what's the first thing we do? Yeah, we've got the for line and log file. It goes to our log file. It asks our log file, I would like the first line of code. So we're back up all the way to the top of our program here pretty much. We ask for the first line of this log file. We jump back into here. What does matches do with that line? Right, it passes it to that user re.search. It passes the line in there. Where do we go after matches? Why were we even looping over matches? Where were we before this? Yeah, we were in days. The whole reason we're asking this question is days was looping over matches. So we ran the regular expression against it. We got a regular expression object. We ask if match. If it is a regular expression object, we make this tuple. Where do we go from here? What was looping over days? So our loop at the bottom here was looping over days. Who is in a days? So generators in Python, generators are kind of magical. They're lazy iterables. They're lazy single-use iterables. We make one of these with the promise that if you start looping over me, I'm going to give you items. I'm going to calculate what they are and give them back to you. But then what we do afterward is we say we're going to make a generator. We're going to take that generator and make another generator around it. We're going to loop that original one, loop over that original one and make a new one. And then we finally loop over that one down here and do some work. So our program is kind of tracing through itself as we loop, because that's how generators work. They're a little bit magical. Who has ever, who's written, you've been in a Unix shell, Unix or Linux shell. Who's ever used the pipe operator? Yeah, so that pipe operator, this is kind of how generators work. We make one generator. We can take another one that sort of pipes the first one into it. We're looping over the first generator. No work has been done yet necessarily. We pipe to the second one, the third one. As we get values, they pass through that pipe. So data processing pipelines, when people use that word, you should think generators are kind of like pipes. They're kind of like pipelines. Maybe we want to reach for generators. So we're going to do some exercises on generator expressions now, and then we're going to jump into actually talking about generator functions in Python, now that we've talked about list comprehensions and generator expressions. Who, by the way, I asked you this before, I can't remember though, who had made a generator expression before this point? You'd made one of these. Okay, so for the many of you who didn't, I really want you to get experience with this exercise section here, because we are going to be doing a little bit more mind-blowing things after this section. So on the website where we're at, we are at generator expressions in the generator exercises section on the website. The file that we're editing, what is the file called? It is called generators.py, and the first exercise is sum all. When you have a question, when you get stuck, when you just want to talk about Python or rubber duck, put up a red sticky. If you want to talk about life, want to talk about anything at all, put up a red sticky, and myself or one of the TAs will come around and chat with you. If these generators are giving you an existential crisis, put up a red sticky. It was a loaner. Oh. Yep. All right, so I know that I didn't give you enough time. There's never enough time. We are going to work through this first one together, though, on generative expressions here. I purposely put more exercises on the website than you could possibly get through. This section here, I'm speeding a little bit, mostly because I really want to get to the fun stuff, talking about generative functions, and we'll talk about iterators in Python. These generative expressions kind of set us up for the next thing we are going to talk about. So, where am I? Here I am. Exercises. Back to the exercise directory. What file are we in? Generators.py. So we're going to do sum all. What does sum all accept? How many arguments and what are they? Yeah, list of lists. So I'm passing in a list with another list inside it. A list of whats? Yeah, numbers or integers, some kind of numbers there. So I'm going to call this a matrix. You can call this whatever you want. We've got a list of numbers. We're going to do this without any generators at all. How can I do this without generators? What am I going to want to do with this matrix? Yeah, loop over it. For row and matrix, what else am I going to want to do? Another for, so for n in row. And then what do I do with that? Right, I need to somehow store this somewhere. So I need total equals, what's total going to start at? So start at 0, total plus equals n, return total. So we have no generator here. This passes our tests. When we made a list comprehension before, when we copy-pasted our way into it, what did we need? What parts of our code, what did our code need to look like? We needed a for. What did we need after that? Yeah, maybe an if, sometimes an if. What else do we need after the if there is an if? So I'm going to bring something up here real quick. If you ever forget how to copy-paste your way from a comprehension, from a loop to a comprehension, I wrote a blog on it. Blog isn't actually supposed to be the thing you refer to as the article. Blog is the whole thing. I just improperly used that word, but no one cares because you all know what I meant. So there's an animated GIF here. I've got a for loop. We copy the append first, then we copy the for, then we copy the last thing as the if. So if your code can be written in this format, for, maybe if, and then an append afterward, and we have an empty list we start with, it can be copy-pasted into a list comprehension. If you cannot figure out a way to write your code in that format, you can't make a list comprehension. We're in a different arena here. We have no append at all. Right, the sum function. So we have no append. If we were to make an append, what would we be appending? Right, each of these things, numbers.append n. We've just unnecessarily built up an entire list of lists. How do we get the sum of those numbers? Yeah, that sum function we use, so sum of numbers. So this kind of looks like something we could copy-paste into a list comprehension. Now this is less memory efficient. We wouldn't probably write code like this. But if we were to make this into a comprehension, we could then make it into a generator expression. So what's the first thing I'll copy-paste? What's your guess? N. The thing we're appending. What is the next thing? Now this is a little bit weird. What is different about this for loop? It has two fors. Which for do we want first? The outer one or the inner one? Who's guessing the outer one for matrix and row? Who's guessing the inner one first for n in row? That was a lot of guesses for the inner one. So in English, I like to say n for n in row for row and matrix. This is how we would normally write this out in English, n for n in row for row and matrix. That does not work in Python. If I try this in Python, anyone try this and get an error? What was the error? Maybe you all did it right the first time. I I saw a lot of hands for that, so I'm guessing you didn't actually get to this point here. So row is not defined is the error we end up getting. Why do I get this error? What's your guess? Right, yeah, so we're executing this code in order. Python's executing it in order here, in a strange order, because the append doesn't get executed until the end. We do this loop first, and then this one. We don't have a row yet, so we have to flip these. So the way I want you to remember this is it's the exact same order as the for loop. We've got outer for, inner for, maybe an if. Outer for, inner for, maybe an if there. And we have our outer for and then our inner for. So we've made this into a list comprehension. Questions on this? Thoughts on this? Now that I've made a list comprehension, how do I make a generator expression out of it? Yeah, turn those brackets into parentheses. Do I need that numbers variable? I don't need that variable. I could just stick this inside the function. There's something here that I neglected to mention. Some of you may have seen this before. It's kind of a cool feature of Python. What's weird about this code? Looks kind of odd syntactically. Yeah, we got parenthesis, parenthesis, a bunch of stuff, parenthesis, parenthesis. Normally when we have two parentheses, it doesn't mean much unless we're maybe making a tuple or something. With generator expressions, the Python core developers made it so that if you had a generator expression that was inside parentheses, that was the only thing that was inside it was that generator expression, you can remove those extra parentheses. So we don't actually need those extra parentheses, which is kind of neat. So we've got sum of n for row and matrix for n in row. Questions on this? Thoughts on this? All right, we are going to take a break here in just a moment. Before we do, I want to show you one thing that we're going to talk about after the break. So I have a file called widgets.txt. It has widget reading 1, it has a name, it has battery, RPM temp, widget reading 2, a name, battery, RPM temp. So this is a very strangely structured file, but we have to do something with this file, and we want to make groups out of this. Groups where we have one widget that has a name, a battery, RPM temp, and another widget where we've grouped those same things. So fortunately, this code has already been written for us that does this. It's in a file called readings.py. It opens up our widgets file, it loops over each line, and passes those lines to get widget groups. So we take the whole file, we pass it to get widget groups, we loop over them and print the result. So this function up here, it accepts a file, it loops over them line by line. What is this asking? What question? Which of our lines would that match for, rather, that line 6? Yeah, line 1 and line 6 there. So we're asking, are we at the beginning of this group? Group equals curlies. What do those curlies represent? Yeah, not a set, actually, a dictionary, which is confusing in Python. We use the same notation for both. So we've got an empty dictionary, and we've got groups.append to this empty dictionary, which is sort of a weird trick, because what we're doing is then we're changing the dictionary later. So we don't really need to know how this code works. We don't care so much how it works. The thing we care about is that we can execute it and get these groups. So my code's taking a while, and then it prints out all of these dictionaries. We are going to talk about how to make it so our code doesn't take a long time before it starts printing things out. So the same thing we saw before, when we had a list, we turned it into a generator expression, a list comprehension to a generator expression. We don't have a list comprehension here. And in fact, we can't even make this into a list comprehension. I'm going to say that as a matter of fact, even though there might be some possible way to do that. Why do I say that? What is my guess that we can't make this into a list comprehension, this big for loop? Yeah, we have an else. We don't just have an if. Not only that, we've got some complex logic going on here. We've got a dictionary, we append it, then after we've appended it, we modify it. which is a little weird. So comprehensions, we don't have the recipe to copy paste from a loop to a comprehension here. We're doing more logic than that. This is too complex for a list comprehension. We are still going to make a generator, and I will show you how to do that after the break. So it is currently 3:07. Our break is it 30 minutes? 20 minutes? How long is the break? 20 minutes? I heard 20, so if it's 30 minutes, someone better speak up. All right, I'm going to give you 23 minutes. So at, just made math hard for myself. At 3:31, we will start up again. So I'll see you all back here in a little bit. If you have questions during the break, do feel free to ask. I'll be wandering around.
sorry. Right at me.
Right there. Thank you. So we're not quite getting started yet, but I want to kind of ask the majority of you who are back in the room already, who this is your very first PyCon? First PyCon. Excellent. Oh, that's wonderful. So that's a lot of you. If you have not already Googled, what do I do on my first PyCon, and found blog posts on this, I have some blog posts to recommend. So the Real Python website, realpython.com, just recently put out a blog post on what to do your first PyCon. I also put a blog post out last year, which is very much still relevant this year, on how to have a great first PyCon. And in that, I actually haven't updated it to link to the new ones, but I linked to, this is, by the way, it's kind of a book of a blog post. It is a very long blog post, so if you are bored in the next day, you know what to do. You can read this. At the very bottom, though, if you scroll to the end, I have some links to other blog posts, Beginner's Guide to PyCon 2015, and How to Do PyCon by a couple other folks. Those are much shorter. So if you want the short version of these, go to those posts. If you want the long version where I talk about all the various aspects of Python, feel free to go through that. And if you do have any questions, if you spot me floating around in the hallway during PyCon, please come up to me, say hi. If you spot any of the TAs, come up to the TAs, say hi to them. PyCon, we're all about community. So if you are, a first-timer at PyCon, try to anchor yourself with the people you've already met to meet the next people. Any questions? Any questions on PyCon, on generators, and anything else? So for those who came in a little bit late, I think there's still stickers in the back of the room for Python Morsels. It is a Python exercise subscription service. I like to call it a Python skill building service. Neither of those terms make any sense because they're both made up. I send out one exercise every week. The exercises are very similar to the exercises we've been working through. So I give you tests. Your job is to get the test to pass. You choose your skill level, and I will help you grow your skills in various areas of Python. So if you're interested in something like that, feel free to sign up. The first month or so is free. If you want more after that for free, email me. I have beta testers, I have discounts, that kind of stuff. I love helping people continue your Python journey. Once you get started in Python, once you've taken a class, it's very hard to figure out where do you go from there. You have to have a project to work on. You've got to write some actual code to keep on making sure that your skills, they continue to grow and they don't gestate. That those skills don't, well, they do gestate, that they don't atrophy, is the word I was looking for. So we are going to get back to our example here on this function, if I can find my cursor. What was the problem with this function? When we ran this code, what did it do that wasn't so great? Does anyone remember? Took a long time, yeah. It's not that it just takes a long time. It takes a long time to even show us anything. It'd be nice if, as it found these groups, it would actually give these groups back to us lazily. So without knowing how to do this, how might you guess to do this? What words would you look up in Google? Google, of course, is half of writing code. So we go to Google, we type in something we're looking for. What would we type into Google to maybe look for how to do this? Some guesses, ideas. I'll remind you now that you've come back from the break, you're sleepy. This is an interactive session. You're allowed to shout things out when I ask questions. If they're wrong answers, that's better because we can talk about them. Yep. Lazy parsing. Yeah, lazy parsing. Doing something lazily. That lazy thing is a good thing to search for. What else might you search for? Generators. Maybe generators. We just did generator expressions. Those seem lazy. Maybe generator version of function or lazy function, lazy parsing. There is a term that we're going to talk about here that I have not mentioned yet. Iterators. We're going to talk about iterators later. We're not yet going to talk about iterators. We're going to continue talking about generators. Who knows what an iterator is? Okay. I'm glad most of you aren't raising your hands, because you probably shouldn't be in here if you know what an iterator is, or at least if you know what they are in Python. If you know the iterator pattern in other programming languages, we're going to talk about those as they actually are in Python. So you will still learn something if you know what those are in other languages. Who has seen me talk about iterators before? Good. Nobody. That's wonderful. We are going to talk about iterators later. You are going to get experience writing your own iterators. We're going to set that aside for the moment and talk about generators. Before we confuse ourselves with yet another term, we've already talked about generators. How did we make a generator? Before the break, what did we do to make a generator? Yeah, change square brackets to parentheses. What were the square brackets in or on? A list comprehension. N squared for n in numbers. We had a list comprehension. We changed those square brackets into parentheses. We made a generator object. The type of this thing is generator. And in fact, we can remove those extra parentheses if we want and get that. I can take this generator thing, pass it to sum. What will that give me? Yeah, the sum of all these numbers. It'll sum up these squares, which is 104. What if I pass it to tuple? What will that give me? What's your guess? What does tuple accept? What type of thing? An iterable? Something that's immutable. So it makes something that's immutable. It makes a tuple out of it. It accepts any iterable, anything that we can loop over, a list, a set, another tuple. So it accepts a generator. It loops over that thing. This is not a tuple comprehension. It looks kind of like one because it's a comprehension syntax and we have the word tuple. What is this that I just wrote? If not a tuple comprehension, how would you describe this animal? A list? So it's actually not a list, but we could make this into a list. If I said, actually, in fact, if I pass this to list, I'd make it into a list. This is equivalent to this. What is this thing that I'm doing? What is it that I've made in here? What's the type of that thing? Anyone want to guess? A generator. I made a generator expression, not a list comprehension, because I removed those square brackets. So very, very close to a list comprehension. So I didn't make a list. I made a generator object because I made the generator expression. What am I doing with that generator expression? Yeah, I'm passing it over to the tuple function, or really the tuple class, but the tuple callable. We're calling tuple, this tuple thing here, with a generator object, and it converts it to a tuple. The same way we can pass any iterable, anything we can loop over to tuple. So it's not a tuple comprehension. It's a generator expression inside or passed into the tuple constructor. But it does look kind of like a tuple comprehension. So generator expressions are really powerful because if you want a list comprehension, but a different flavor, like something the equivalent of a tuple comprehension, or a counter object which lives in the collections module in Python, you want a counter comprehension, or an ordered dictionary comprehension, or some other type of data structure, and you can pass an iterable to it, you can make something kind of like a comprehension out of it. You make a generator expression, it's lazy, you pass it into that constructor thing, that callable, and you've just invented your own type of animal. We're kind of composing these things here in a sense. So we're going to take this code that we had here and we're going to make it lazy. We're going to Google generator function Python and see what comes up. What we'll end up finding is this append here. This append and the return, that's what makes this problematic for us. We don't actually want to be returning a list from this function. We want to somehow return a generator. So I'm going to do something here that when I first saw it, it was kind of mind-blowing because it's weird. It's a very weird thing in Python. We're going to take a whole new syntax. Anyone know what I'm going to type here? Yield. I'm removing the list. I'm removing the return. Ooh, this was a problem. What is it doing? Returning an empty dictionary. Why is it doing that? I told it to. How did I tell it to? Right, empty dictionary equals, group equals empty dictionary, and then I yield that empty dictionary. So we have to change our code to somehow yield the fully created dictionary. Anyone want to guess how to do that? Where would I be yielding? We have not yet talked about this yield thing. We're going to talk about it in a moment. It is new, and it's a little weird. It's kind of like a yield sign. Does anyone know how yield signs work in traffic? I'm raising my hand despite the fact that I don't understand how they work. From my understanding, they're sort of like a mix between a stop and not a stop. Somewhere in between there, you're yielding. Yield is sort of like that in Python. It's not a stop and a not stop, but it's this weird, confusing thing that we don't quite understand. We have to look up how to use it. So we're going to talk about yield in a moment. Without quite understanding how this works, what's your guess for how we might yield the right thing? put it at the end. Yeah, there's some kind of beginning here. We're making an empty dictionary, yielding it. We want to somehow say, once we no longer, this dictionary isn't empty anymore, we somehow want to yield. So how I'm going to do this, I'm going to say, we're going to start group at none. This is one way to do it. And we're going to say, before we make an empty dictionary group, if there's a group, if we already have a group, we'll yield it. After that, we make the group an empty dictionary again. So a little bit weird, but I just rewrote my code to do the same thing it did before, except that it is somehow lazily giving us all of the answers we were looking for because of that yield. So this is a pretty complicated function. We're going to look at a simpler example in a moment because I don't want you to get hung up on what it is we're actually doing in terms of the logic here. I want to talk about this yield. What is yield doing? How is it different from return? What's your guess? When you return from a function, where do you go to? You're inside the function. When you return, where does it go? Yeah, the person who called our function goes back to them. You're returning some value to them. When we yield, where does it go? Sort of the same place. Kind of goes to the person who called our function, but it doesn't go here. It goes here. For group in this thing, we get a new one. It yields one value. I do something with it, and then when I start looping, where does it go? What's your guess? Where does it go in this function after the first thing I've yielded, do you think? Back to the top of the loop, maybe? Yeah, so let's try this out. We're going to try it with a much simpler function. We'll jump into count. Count's going to be a function. It starts at, defaults to 0. And we're going to say, while true, what is this? Infinite loop. We're making an infinitely long generator. We're going to yield, and then say n plus equals 1. So I will call count, and I'm going to say c equals count. If this is a generator object here, which we'll see if it is a generator. What can I do with this? Yeah, I can loop over it. I can call next on it, which is kind of a way to manually loop over it. So I can loop over this thing, or I can call next on it to manually loop. What's the first thing it'll give me? What's your guess? 0. What's the next thing? What do you think? 1. What after that? 2. It's just going to go upwards for forever. When we call this function, because it has a yield statement in it, it doesn't give us a return value. It has a yield statement in it, so it gives us a generator. So I'm going to make a function called do nothing. We're going to revisit that count in just a moment, but do nothing is going to say if false, pass. Anyone know what pass does? It does nothing. It passes. It's a no-op in other languages. It does nothing at all. So this is a line of code that does nothing. So when I call do nothing, what type of thing will I get back? What's your guess? Who thinks a generator? Who thinks something else? Yeah, it is not a generator we get back. What's your guess that the type of thing is? A class? So normally when we call a function, we get back the return value. What is the return value of this function? We didn't even return. Yeah, some kind of void equivalent. In Python, we call that none. So the default return value in Python is none type, or none, really, is what we get back. So we get back none. So we got back none from this. I'm going to rewrite this function to be very slightly different. If false, will if false ever be true? We hope not. If false shouldn't be true, so we're going to assume that it's not true. We're not living in some kind of land where false can be true. So x equals do nothing. What type of thing do you think I'll get back here? What's your guess? We got back none before. What do you think now? Who thinks we'll get none? We got none before. We might get none again. Who thinks we'll get something else? Must be something else, otherwise why would I be asking you this question? X equals do nothing. We got none before. This time, we get a generator. Why did we get a generator? The only line of code we changed was this, and we weren't even executing this line of code. Yeah, I put a yield in the function. If there is a yield statement in your function, you are not working with a function. Functions have return statements. If you see a yield in a function, there's no more return. You're not in return land. You're in yield land. You now have a generator function. Simply by the presence of a yield, you don't have a function anymore. You have a generator function, a totally different type of animal. We have the same syntax for making a generator function as a classical function in Python outside of that yield, though. Question? Good question. So yeah, let's try it out. If false, we'll yield 0, and then we'll say return 4. So do nothing. What is your guess? So who thinks here we've got do nothing, it returns 4. If false will never be true, so that's not even going to get executed. Who thinks we're going to get 4? Who thinks we'll get a generator? Who thinks we'll get an error? Who thinks we'll get something else? No one for something else. All right, I can't trick any of you. So x equals do nothing. We didn't get an error. We got a generator. What's your guess that will happen when I call next on it? Stop iteration. So you're guessing it'll be empty because we're not yielding anything, maybe? Stop iteration 4. So a little bit weird. They actually changed this, I believe, in Python 3.8, I might be right, or is it Python 4 it will eventually be changed? I know that this will be changed in the future. And if you want to change this behavior, you can import, I think it's from dunder future import, and now I forgot what the rest of it is, but it's importing a, I believe it's generator something. They're changing this behavior to be an error, I believe is how it's going to work, because this doesn't make any sense. Returning from a generator shouldn't be a thing that's sensible. You should be able to return, you shouldn't be able to return a value. That's a little weird. All right, so we're going to go back to count there. Count n equals 0. And I want you to make some guesses as we're going through this. So I'm going to say while n is less than 10, just to put a limit on this, yield n plus equals 1, and then we'll print loop and print end. What is your guess that this will print? What do you think it'll be nothing? You think it'll be start? What else might it be? End? So who thinks it'll print start? Who thinks it'll print nothing? Who thinks it'll print end? So most of the guesses were for start. Why does it print nothing? Right, we called the function. Normally when we call a function, our mind's being tricked here. When we call a function, the function gets called. When we call a generator, the generator doesn't get called. How do we get this generator to do something? Iterate over it. We loop over the thing. So we call the generator function. It gives us a generator object back. When we start looping over it, it'll actually start executing the function. All right, what's your guess that this will give me when I call next C? What's your guess that it'll print? So start and loop. Start and loop once. So who thinks just start? Who thinks start and loop once? Who thinks something else? So it is just start. It's just start. What is x? 0. Questions on this? Thoughts on this? Why didn't it print out loop? Right, the yield happened before loop. So you can think of generators, whether generator expressions or generator functions, kind of like you're watching Netflix or YouTube. You're watching a video, and it's a long video, you're in the middle of it, and you decide, I'm going to pause this because someone just rang my door, and I'm going to go to the door and get whatever food was delivered or something, handle whatever's going on there. We're inside the for loop, we're doing the work over there, and then we go back to the thing we were watching, and we press play again. Generators are a way to put a function on pause, to put an iterable on pause. They're kind of a contract between the for loop that's looping over them and the generator function itself. Yield delegates work from us, the generator object, and says, for loop, do your thing. Next time you ask me for an item, I'm going to start executing myself again. So we put our function on pause with the yield, and we haven't done any other work. What's your guess that this will print? Where do we start up? We've put ourselves on pause. Where were we when we paused? Which line of code do you think? Yeah, we were at the yield. We yielded. So where will we start executing? What's the next line of code? Right, the n plus equals 1. Where will we stop again, do you think? The yield, which is a little weird. It's the same line of code, but we need to do some work before then. So what's your guess that this will print out? Loop? How many times do you think it'll print out loop? We will see. So it prints out loop once, and x is 1. So generator functions are kind of a little bit easier to trace through than a generator expression, because we see that yield there. Yield is weird and confusing because it's a totally different animal. It's something we've never seen before in Python. But once we get the gist of what it is, just like when we first learned about for loops or return or all these other programming paradigms, we can get that it's a dance that the generator function is doing with the for loop, that each of these are collaborating with each other. They're delegating work back and forth. Questions, thoughts on this? What's your guess that this would do? List of, oh, sorry, not list of X, list of C. First, what do you think will be in this list? We started at 0. What number do you think we'll end at? 10? 9, 10, 11, someone in there. So, unless we have an off by 1 error, you know, keep all our bases, either 9, 10, 11, somewhere in there. So the numbers it's going to generate, which will be the next one? 2. So we end up going from 2 to 9. And it printed out as many loops as we put values in our list here. Actually, I don't know if it did, now that I think about it. We'll have to count those up, but no, it did, because there was no early break here. We got every one of those loops, and we printed out the end, only when we get to the end of the function there. All right, questions on generator functions, thoughts on these? Yes, if you see a function, how do you know if it's a generator function? Any function in Python, you see def something, how do you know this is a generator function I'm working with? It has a yield. If it doesn't have a yield, it's not a generator function. If you see a function with a yield, what do you know about it? It's a generator function. So this is kind of an if and only if situation. If there's a yield, it's a generator function. If it's a generator function, it has to have a yield. It is a different type of animal you're working with there. Functions don't have a yield. Generator functions do have a yield. It doesn't matter if there's a return, if there's no return at all, that's a regular function. If there's a yield, it's a generator function. Other questions? Yep. Next C, good question. What's your guess? Stop iteration, an exception of some sort? So we saw before when we were working with generator expressions, we loop over these once, they're single use. And so we can't loop over it again. And there's no restart, there's no previous. So we get the same thing as a generator expression, we get that stop iteration exception. And same thing if we were to loop over it again. I get an empty list if I loop over it again, because it is empty, there's no more values in this thing. Other questions? Yep.
How would we reset a generator to be used again?
You can't. So the question was, how would we reset a generator to be used again? In the generic sense, you can't. However, I'm going to say something that's confusing. Then we're going to forget I said it, and I'm going to say it again later. Generators are iterators, and they are also iterables. And iterators, you can do whatever you want with in terms of adding extra functionality, adding a reset, adding a previous. You can do whatever you want because they're classes, and classes are a little bit more powerful than a generator, which we're kind of stuck in generator land. We don't have much control over that. So when we talk about iterators, we'll talk about how would we possibly make up a reset. Files are kind of like a generator with a reset. Now, what I just said is technically incorrect, but it's an approximation of what's actually reality. And we'll talk about that when we get to iterators. So ask that question again once we start talking about iterators. Yep.
So I hesitate to ask this, but if you wanted to generate slightly differently in those situations, like you could imagine a generator referring to variables to behave differently.
Right.
Is that an anti-pattern? Should we just never do that in a generator?
Not necessarily. It depends on how different it is. So for example, if we were counting and we wanted to say count n equals 0, step equals 1, you know, we would change the way we're actually counting there. We'd say while true, yield n, and then what would I do here? Before I did n plus equals 1, what would I do in this case? Yeah, n plus equals step. So it depends on how different what you're doing actually is. Oop, I need an equal sign there. Ooh, that didn't work. Oh, it didn't work because I didn't add a step. I meant to add a step of 2. So it did work. Python did exactly what I asked it to, just not the right thing. So it depends on how different it is. You can always vary things a bit, but you know, in Python kind of leaves things up to us. If we're changing our function to do a totally different bit of behavior, we probably want to write a different function. All right, I want to show you a little bit of syntax, and then I'm going to ask you for some more questions, and then we'll kind of jump into exercises. So one thing I haven't mentioned here, I talked about yield. There's something you will see if you're in Python, I think 3.5 and above. Sometimes people write code that looks like this. So I'm actually going to jump into IPython. Anyone used IPython? So IPython's kind of fun. It is a Python interpreter that... Well, I'll show you what it does. What is it doing differently? How is this different from what I was typing in the Python Repple before? Yeah, it's syntax highlighting. How is that different? Right, it inserted an indent for me, which is kind of nice. So the Python, IPython REPL is kind of a nicer version of the Python REPL. So I'm going to type element or for item in elements. If there's some condition that's true on this thing, then we will yield. I'm going to do with this condition, if the item does not equal 0. Maybe we'll skip the zeros. And then we'll yield that item. So when I call do something with 1, 2, 0, 3, and 4, and I loop over this thing, get a list out of it, what will it give me back? What's your guess? I'm hoping 1, 2, 3, 4 if I wrote the code correctly. It does give me 1, 2, 3, 4. So this here, if you end up with a loop that doesn't have another loop inside of it, but instead has, or sorry, doesn't have a condition inside of it, but instead has another loop, we're kind of doing a deep nesting. There's another way to solve this problem. So I didn't actually mean to write this. I was going to jump to the exercises. What's the exercise where we had 2 loops inside each other? Anyone remember? All? Yeah, we're going to go to the exercises directory here. So in the generators.py file, we had sum all. We also had all together. I'm going to take a look at all together. So all together, what did it accept? How many arguments? Any number of arguments. Anyone know how to do that? Yeah, star, which is kind of a weird thing. So star iterables. For iterable in iterables, I want to take each of the items in here and make a generator that gives us those items back. So if I type yield iterable, this is going to give us the whole iterable. So you may not have gotten to this part of the tests. That's okay if you didn't. This isn't quite what I'm looking for. For anyone who solved this, how did you do this? We didn't do this with yield. We did it with generator expressions. How would you do this with the generator function? Yep. Right, you've got two fors. You had in there, your generator expression, you had a for iterable in iterables, for item in iterable, and then what did you yield, or what would we yield? Yeah, the individual item there. So you solved this, some of you solved this with a generator expression before. A generator function is to a generator expression as a for loop is to a list comprehension. We had a for loop that built up a new list. We can turn that into a list comprehension sometimes if it's written in just the right format. If we have a generator function like this, we can turn this into a generator expression. What's the thing that I would put first? In the item, why item? In a list comprehension, what's the first thing we put? Yeah, the thing we're appending. It'd be item there, the thing we're appending. We're putting the thing we're yielding. The thing we're yielding, and then what order are the for loops? Yeah, same as this order. So for iterable and iterables, for item and iterable, we're going to remove those colons. These two are equivalent. Now, these are not the same thing. These are both functions that give us a generator when we call it. This has yield in it. When we call this function, what do we get back when we call this function? A generator, because it has yield. What do we get back when we call this function? A generator, but there's no yield. Why does it give us a generator? Right, it's those parentheses, which is kind of tricky. We're making a generator expression, so a generator expression is kind of an inline version of a generator function. We can make a generator object and pass it off to something else. This is the long form of it. If you prefer the long form, or you need the long form because you really can't write the short form in your code, you need to jump into a whole different function and make a yield there. There is an even shorter way to write this in Python 3.5 and above. It is yield from iterable. So what this is doing is it's saying, look, there's this iterable thing. I don't know what type of thing it is. It could be a list. It could be a tuple. It's something that's iterable, though. It's something we can iterate over. I want you to take each of its values and yield those from my function individually. So it's a shortcut for writing a loop and yielding. That's all it is. It's just a common enough thing to do in generator functions that we have a yield from syntax now in Python. All right, questions on generators and generator functions? Who finds these things confusing? These are weird. Who's perfectly fine with these? You think you've got a great handle on these? I'm raising my hand despite the fact that I'm not entirely sure of myself. You think you've got an okay grasp, but you really want some practice on these? Good, excellent. We're going to work on exercises. So if you have questions, but you don't want to ask them in front of everyone, ask me or ask one of the TAs during the exercise break right now. I call it a break. This is not a break. It's a break for me. It's not a break for you. You need to write some code. So we're going to be in the generator functions section on the website. And we are at the bottom of the page, generator function exercises. Please do work through these. If you've never seen generator functions before, remember that you do not learn by putting information into your head. You learn by attempting to retrieve information from your head. You've got to write that code through your fingertips to try to practice this stuff to actually learn it. So any questions at all, put up a red sticky, and myself and the TAs will be floating around. class exercises. They're not really ever going to make iterator classes. And so probably this is our last exercise break. Probably for the rest of it.
Yeah.
'Cause it's
got
4:40.
45 minutes.
Yeah, okay. Let me give it until 4:20.
You go through and solve exercises with him. Is that what you're going to do?
Oh yeah, I forgot about that. Maybe I'll do 4:18. Yeah.
Yeah, 418, definitely.
10 minutes just isn't very much.
10 minutes?
Yeah, for exercises, like from here. It's 4:08 right now.
Oh, I see.
I'll give them a little bit more. Remember that there are more exercises on the website than you could possibly get through. I don't expect you to get through all these. If after this tutorial, during PyCon, maybe while you're at home, you want to solve some of these, you will have access to this website for forever. I'm going to keep it up as long as I can. And you can always work through these exercises on your own. I do want you to try to get practice with these here in the room while we're here together so you can ask questions, though. Any questions at all, put up a red sticky, even if they're questions that are completely unrelated to what we're doing.
Just gotta read through it a second time. I wrote is not instead of not is.
right, we're going to take a look at this first one together. So unique, what does unique accept? What type of thing and how many things? How many arguments does unique accept? Seems like it accepts one. It says take 0 position arguments, 1 was given, so it should accept 1. We'll say it's an iterable. So what can we do with this iterable, do you think? Yeah, we don't necessarily know. It could be a list, it could be a tuple. We can iterate over it, we know that. So we'll say for item in iterable, we need to know whether we've seen this item before. So ignoring that, how would I get all of the items? How would I make a generator function where I loop over something, it gives me all the items? Yield. I want to yield the item there. So when I loop over this thing, it would give me all of them. Now this doesn't work because we're only supposed to get the unique ones. How do we get only the unique ones? How would we know whether it's unique? Make a set of some sort? So we want to know whether we've seen this thing previously. Before we yield it, if we haven't seen it. If we have not seen item, then we yield. Then we just need to write a we have not seen function at this point. So we have not seen, we need to write this condition here. You're saying use a set. So set, what would I call this set? Uniques. Uniques? So I'm going to do this. Why can't I use curly braces to make a set? Yeah, it's a dictionary. So we unfortunately have to call the set constructor. There is actually another way to do this. Who finds this readable? I'm raising my hand even though I don't. No one finds it readable. That's why we're going to call set. This technically works. It's kind of a weird hack. If you are new to these weird asterisk things, if you search Google for Python asterisk, my blog post is somewhere in the top 3. There's all 3 of the things you'll find, though, and the top few Google results are useful. That asterisk thing is weird. It has a lot of uses in Python. We're going to make a set. Once we've got this set, we have each of our items, we're looping over it. How do we know whether we've seen this item? If item in our set. So if it's in our set, do we want to yield it? We don't want to yield it. So what should I do to fix this code? Right, I need to invert the whole thing. I could say not. How else could I do this? Yeah, the Python core developers made an operator that has a space in it, not in, just because they wanted to make it easier to type not in, to make it more like English instead of like Yoda speak, not item in uniques. We say item not in uniques, we're allowed to do that. And that still fails our test. Why is it failing at this point? Oh, we're not updating the set. How do we do that? Yeah, uniques.add item. Should I do it outside or inside my if? Inside? Outside? They both work. Why do they both work? Yeah, if you add an item to a set, it's already in there. It's not going to do anything. So we'll put it inside it just because there's not much point in putting it outside. So we are yielding here. We're checking if it's in the set. Now, we're storing memory. This is a generator that builds up memory. Generators aren't supposed to take up memory. Are we cheating? Maybe, sort of. We don't necessarily know if someone's calling this function, they don't know whether we're taking up memory. That's up to us. We kind of have to take up memory because there's not a way to know, have we seen this thing before? Why did I use a set instead of a list? I could have used a list here and appended. That would have worked just fine. Why didn't I do that? It's not unique. It's slower. Why is it slower? It's slower actually because it's not unique. Anyone know why? Yep. Not sorted per se, but it's got this magical ability. It uses a hash function under the hood. So it's hashing its item to see, is it in my set? So this operation, not in uniques on a list, is a very slow operation. It loops through the entire list. On a set, this is a very fast operation. We hash that object, we look at its hash value, see if it's in that set, and it knows the answer to that question immediately, regardless of whether there's 1,000,000 items or just 100 items. I'm not going to explain how that works. If you want to know about hashability, we can maybe talk about it in the hallway afterward. This is uniques. I want to solve one more of these together. Before we do, though, we've only got about 10 minutes left, 13 minutes left, I guess. Before we wrap up, I want to talk about this thing I mentioned earlier. What's the word that I mentioned that I didn't explain? Anyone remember? Iterator. Iterator is the word I mentioned that I didn't explain. So I am going to try to explain that word. Now, that's sort of a weird word. Yep. Yeah, this did not work because what does star do? It accepts any number of arguments and sticks it into a tuple. We want one argument. You do not want that star unless you want to accept any number of arguments. If you've never seen that star before and you're tempted to stick stars everywhere in your code, search for Python asterisks. Asterisks in Python, that second result that comes up, it's a blog post I wrote on it. And stars, there's a lot of ways to use them. You don't want a star here. We want to accept one argument to this function. All right, we've only got 10 minutes left. So iterators, what is the type of this thing? What's your guess? Yeah, it's a list. If I say next numbers, what do you think we'll get? An error? 1? Yeah, when we say next on a generator, we get the next item. We get 1. On a list, we do not. It says list object is not an iterator. Next only works on iterators. What have we been passing to next? Generators. So what are generators? By the process of this deduction here, list object is not an iterator. We've been passing generators to next. What are generators? Iterators, which is a little weird. We haven't talked about this term. We've been talking about generators, though. We've got squares. We said next squares this worked, which means it must be an iterator. So generators are iterators. Iterators are the thing that does the iterating. An iterable, you are able to iterate over. You can use it in a for loop. An iterator is the thing that actually does the iteration. So if I have numbers, I can get an iterator from it using the built-in iter function in Python. I can say I equals iter numbers. What can I do with that I? I can call next on it. What will happen if I index it? What's your guess? We get 2, we get an error. We do get an error. This iterator thing, which is apparently a list iterator object, we don't really care what it is, though. We care that it acts like an iterator, the same way we care if something acts like an iterable. The only thing we can do with it is call next on it. There's one other thing we can do, actually. What could we do with a generator besides calling next on it? List, yeah. What does list do on a generator? What is it doing under the hood? It's iterating, and how do we iterate? What construct do we have in Python for iterating? A for loop for n in squares. We can iterate over a generator. So a generator, what does that mean if you can iterate over something? What type of thing is it? An iterable. A generator is an iterable because you can iterate over it. If you can use something with next, what type of thing is it? An iterator. So is a generator an iterator or an iterable? It's both. It must be both. We can loop over it, so it's an iterable. We can pass it to next, so it's an iterator. So we haven't yet solved the problem of what are these iterator things. Iterators are a special type of iterable. You can actually loop over any iterator. Now, it's only giving us 3, 4, and 5 because these are like generators. They're lazy. Iterators are one-directional iterables. They're single-use, lazy iterables, which should sound familiar because that's what a generator is. A generator is our way in Python as Python programmers to easily implement an iterator. If you've heard of the iterator pattern, it's a design pattern, other programming languages have it. We love that pattern so much in Python, we baked it into the programming language. We decided our for loops are going to be powered by iterators. So what we've been talking about here is actually how for loops work. We've been talking about something called the iterator protocol, which is really a fancy way of saying how for loops work in Python, how iterables work in Python. So I'm going to take a for loop and we're going to refactor it to not have a for loop at all. We're going to refactor it to use a while loop. So I'm going to make a file, i.py here, and we're going to say it has a for loop that prints each of its items. How can I take this thing and remove this for loop? So I want to remove this for loop and make a while loop. I'm just going to be lazy and say while true. We're going to figure out our breaking later. I want to manually loop over this iterable. So an iterable in Python, something I've kind of glossed over here, any iterable in Python, you can get an iterator from. How do you get an iterator from an iterable? If I've got an iterable, I've got numbers as a list. What else is an iterable? A string. We could say a string. If we loop over that string, we get characters. How would I get an iterator from that string? What's your guess? Yeah, we did that with a list. It works with a string as well. Any iterable can be passed to the iter function to get an iterator from it. So how are we going to get an iterator from this argument? Iter, and what do I pass it? Yeah, iterable. Once I've got an iterator, how do I get the next item from it? That should have been a big hint the way I phrased that question. Yes, next. Next iterator, so I can say item equals next iterator. And then I want to print the item. Now, what could happen when we call next? If there are no more items, what's going to happen? Right, we get an error. What kind of error is it? Yeah, stop iteration. So if there is no error, I want to print. If there is an error, what do I want to do? Yeah, I want to get out of our for loop. Break, return, we want to escape. Our loop is done at this point. So if we call print each, hopefully this works, this should print out 1 and then 2 and then 3, and it does. So we have just taken what was a for loop, and we re-implemented the for loop using a while loop. This is how for loops work under the hood in Python. So generators are iterators. They implement this iterator protocol thing, which makes them both iterables and this weird iterator thing that we can use with next. Would we ever write code like this? Not really, not often. It's very rare that you're going to ever write code that uses this next thing over and over using a loop because we have a for loop. Our for loop is our special construct in Python for doing this work for us. If we've got an iterable, the for loop will grab an iterator from it and loop over it using next over and over for us. Questions on this? Thoughts on this? I have some questions in my mind I expect people to ask. If no one asks them, I'll just start blurting them out. Yep.
From a memory consumption standpoint, what's the difference between calling iter and using for loop?
So when you call iter, no memory really gets allocated except for kind of a pointer of sorts. It's sort of like a bookmark, sort of saying, where am I in the iterable that I'm looping over? And that iter magic, however we grab an iterator from it, that is up to the object. So what happens under the hood when I say iter numbers is we end up calling numbers.dunder iter. There is a dunder method. Dunder, by the way, what does dunder stand for? Double underscore iter, double underscore. This lives on this object. This is how operators are implemented in Python. The plus operator, the len built-in function, the iter function, lots of things are implemented like this. Iter delegates to numbers. It says, I want you to give me an iterator back. So it really depends on the object, but typically it does no work at all when we call iter. We start doing work when we call next. once we call next over and over. In terms of looping versus manually looping, they're the same thing. Those 2 bits of code I wrote before were basically equivalent. We grab an iterator which doesn't take any memory. We call next, which only, well, it doesn't take any memory either because we're just referencing that one single object. Unless we store that object somewhere, we don't take any extra memory. Other questions? Yep.
So you could have like a whole bunch of different iterators on the same object and advance them independently.
You could, yeah, absolutely. So in fact, that's normally what we do in a sense. We loop, we got one iterator, we were done with it. We loop again, we get a second iterator. So if I've got numbers here, iter numbers, I equals iter numbers, j equals iter numbers. What is your guess that next I will give me? What do you think? 1? What will next I again give me? What do you think? 2? What about next j? What's your guess? 1? It's 1. They're independent. Now, this is the way it should work. This isn't always the way it works, though. The reason I say that, we have a generator. Generators are iterables. What can you do with any iterable? You can loop over it. What can we do to manually loop? We can call next. With any iterable, though, we can get an iterator from it. What do you think next of I will give me? What's your guess? 1. Let's see what's actually in numbers. What about next of I again? 4. What about next of j? What's your guess? So before it was 1. It's 9 this time. These are not independent. The reason is I is the same object as j. These are exactly the same object in memory. In fact, they're the same as the generator itself. When we asked this iterable for an iterator, what did it give us back? Itself. Why did it give us itself back? It is an iterator. Generators, what are generators? They're 2 different things. Iterables and iterators. We asked this iterable for an iterator, and it kindly gave us an iterator back, which was itself. So iterators in Python, every iterator actually works this way. If we say I equals iter numbers, and then we say iter I, that is the same thing as I. The definition of an iterator in Python is it's an iterable whose iterator is itself. There's a lot of ways to define it. That's a confusing way to define it. Iterators are iterables as well, this is where minds start getting blown. This is where I get confused. I have a talk on this that is called Loop Better. If you search for Loop Better Python, you'll see the talk. It's about 30 minutes long. There is more material on the website that we didn't get to. The reason we didn't get through it is I wanted to kind of drive home this fact that iterators are really what's going on under the hood. You don't need to care about generators. You need to care about iterators. Files in Python are actually iterators. So when you asked your question before of, can we open a file? And for example, widgets.txt, this was a pretty large file that we had here. If I open this file, I can call next on it. What does that mean about this file object? It's an iterator. It's an iterable as well, because all iterators are iterables. We can loop over files. We can also call next. Does anyone know how to reset a file? Seek. So files are iterators, but they can be reset, sort of, with seek. Now, if we wanted to make an object that does this, we're about a minute over time here, so if anyone really needs to run, feel free to. I'm going to go on for about another minute, and then we're going to wrap up. I want to take this that we did not solve, float range, and solve it real quick before we wrap up. So float range, this is supposed to accept, for anyone who solved this, what does this accept? Yeah, start, stop, and step. So we have a start, a stop, and a step. And we are supposed to say n equals this start for some item, or while n is less than the stop, we're going to yield that stop, or that value there, and say n plus equals the step. And then we'll see if that passes our tests. This float range that I've just made, which does not pass our tests, step defaults to 1, and that passes our tests. We can actually implement this as a class. Now, this part, you should rewatch the video later because I'm going to do this quickly. I'm going to say class float range. It's going to have an initializer. What does an initializer do? When does it get called? Yeah, when we construct a version of this class, it gets called. I'm going to make a dunder next. Dunder next is what happens when the next function gets called. My dunder next is going to say return self.n, self.n plus equals step. I also need a dunder iter. If I'm an iterator, and if someone asks me for an iterator, what should I give them? Myself. So I've just re-implemented a generator function as a class. I forgot self up here, though. This should be self.step. Ooh, I did something crucially wrong in my next. Yeah, so not just that, I didn't just put the return first, I need to stop at some point. If self.n is greater than the stop value, what do we want to do when someone calls next and we're empty? Yeah, we raise an error. So we want to say raise stop iteration. Otherwise, we're going to increment this, but we need to actually get that value. And then return that value and increment it in the middle. So very complicated here that we just turned this into. This here, it doesn't quite work. I'm going to try to get it to work in a moment. I think I have kind of an off by 1 error. This is the reason we make generator functions. If we didn't have generator functions in Python and we wanted to implement our own iterator, we would need to make an iterator class. This is considerably longer than the generator function I just made with that yield thing. So yield is weird and it's magical, but there's a good reason we have it, because this is a pain to make. A dunder iter, a dunder next, and we have this weird iterator object we've just made. So you are probably never going to need to make an iterator class, but you will probably need to make an iterator. In that case, you can probably make a generator function. When you need a lazy iterable, think of iterators, and then reach for generators, either generator functions or generator expressions. On the website, if you have questions as you're going through the exercises on your own later, there's a couple sections we didn't get to on purpose because I wanted more material than we could get through. You all have my email because I emailed you last week. My email is buried in that email somewhere. It's not actually from me, but I did stick it in there. Feel free to approach me during the conference if you want to chat, if you have a question about something, or if you just kind of want to hang out, it's your first time, you want to meet folks. Also, please feel free to send me an email if you have any questions on the material. And if you are on a team of people and you do kind of want to level up your skills in a particular area within Python, I don't know all of Python, but I know a few things in Python. Feel free to chat with me. That's the thing I do for a living, is on-site training with teams outside of this fun Python morsels thing. Oh, by the way, more exercises. If you do sign up for Python morsels and have feedback, I love feedback, whether it's on my teaching style here, the exercise I do online, anything else. I want to know what's bad, what's good, what's different, what didn't jive with you. So I will put up this survey. I'll email it to you. I'm going to put up the URL. Actually, I'm not going to bother putting up the URL here because I know you're all just going to run out of the room. I'll email you the link to this survey to fill out for afterward. All right, thanks for staying after for a little bit.